Hi! In the previous videos you have learned what differential calculus is all about. In differential calculus you learn to calculate the slope of a curve. In this video I give you the roadmap for differential calculus. If you have the big picture, it is much easier to learn differential calculus. The first thing you will learn in my school is on the left side of the blackboard. The second thing you will learn is on the right side of the blackboard. And the third thing you will learn is at the bottom of the blackboard. Okay, let's start. The first thing you will learn is to find the slope of a straightforward function, like f of x equals x squared. To find the slope of a straightforward function, you just have to look in a table. You find this table on Wikipedia too. The second thing we will learn is to find the slope of a more complicated function. More complicated means the function is, for example, the sum of two other functions, or the product of two other functions, or the quotient of two other functions, or the chain of two other functions. And if you want to find the slope of a straightforward function, you have to use this table, and if you want to find the slope of a complicated function, you have to use this table and this table, both tables. This is the difference. If you have a straightforward function, you use this table. If you have a complicated function, you have to use both tables. In part 3 of the course, we will prove all formulas. We will prove these entries in this table and these entries in these tables. For the proofs we need to know limits, so I have to make a video about limits and the formula from the first video. Let us return to part 1 and let us consider an example. The example says, what is the slope of the function f of x equals x squared at x equals 3? So the first thing is we need the derivative. Where can I find the derivative of f of x equals x squared? In the table. I look in the table and the given function is x squared, and the table says the derivative is 2 times x. So I write my function is x squared and the derivative is 2 times x. The next step is I put in 3 for x. Why do I do this? Because I'm looking for the slope at x equals 3. So I have to put in 3 for x. And I get 2 times 3, which is 6. The solution is 6. The slope of the function f of x equals x squared at x equals 3 is 6. The next thing I have done is I've represented the problem and the solution graphically. In the first picture, we see the given function f of x equals x squared. The yellow graph is the given function f of x. F of x equals x squared. And what are we looking for? We are looking for the slope at x equals 3. So I draw a line here at x equals 3. Now, what was the first step in the solution? The first step was we searched for the derivative, and we found the derivative in the table. The derivative of x squared is 2 times x. The derivative f prime of x is 2 times x. You see the derivative in this picture, in the second picture. F prime of x, which is the derivative, is the yellow graph. The yellow graph is f prime of x, the derivative. Okay, what was the second step in the solution? The second step was we take f prime, the derivative, and put in 3 for x. So we take f prime, the derivative, which is this picture, and put in 3 for x, which means we choose 3 on the x-axis. And we get 6. The solution. The solution is 6. And what does it mean when we say the solution is 6? It means the slope of the curve is 6 if x equals 3. The slope of the curve is 6 when x equals 3. In the second part of the course, I will show you how you find the slope of a more complicated function, a function which consists of 2 or more other functions. Our example is the function f of x equals logarithm of x plus the square root of x, and we are looking for the slope at x equals 9. The first step is the same as in the previous example. The first step was we must find the derivative. The derivative of the logarithm function, I look in the table, the derivative is 1 over x. So I write down 1 over x. Then we have the square root function, and the derivative of the square root function, I look in the table, the derivative is 1 over 2 times the square root of x. So I write down 1 over 2 times the square root of x. In the next step, which is step number 2, we must use this table. Okay, let's use this table. The given function is the sum of 2 functions. And the table says if the given function is the sum of 2 other functions, you must add the derivatives. I repeat, if the given function is the sum of 2 other functions, the given function is the sum of 2 other functions, we must add the derivatives. So we add both derivatives. The derivatives we already know from table 1. This is easy to understand, but perhaps it is too fast for beginners, so I repeat step number 2. Step number 2 says if the given function f of x is the sum of 2 other functions, then the table says we must add both derivatives. So I add both derivatives. Okay, that is step number 2. Step number 2 is very easy to understand. Step number 3 is easy too. We already know f prime, the derivative, but we are not looking for the derivative, we are looking for the slope at x equals 9. So we put in 9 for x in the derivative. And we end up, if we compute this, we end up with 5 over 18. This is the solution. The solution is 5 over 18. Maybe you ask yourself, is it always so easy to solve a problem in differential calculus? No, look at this table, we have used only the second entry, the sum rule. And the first entry and the second entry, they are very easy to understand. I can explain it in 1 minute. But there are 1, 2, 3 rules left, and these 3 rules are complicated. They are difficult to understand. And I need 1, 2, 3 more videos to explain them. Yes, but at the moment you have the big picture. You know there are some things they are easy if the function is straightforward. It is easy to find the slope. If the function is the sum of 2 other functions, it's easy too, but the problems begin here. But don't be afraid, I'll explain it step by step and you will understand it. In the third part of the course, we will prove all entries in Table 1 and Table 2. That sounds a little bit difficult, and it is difficult, but it is possible.